one of our Chinese water dragons we're going to take a peek at. We might even talk about their nervous systems today. Are you down with that, Riley? I think she is. Let me find her. She's ready. Awesome. So let's, what did I just do? There she is. I'm going to put her in presenting. And I want to make sure you have your microphone, Riley.
Yep.
Yes, there she is. I'm going to mute myself so that you can hear her.
He's kind of hard to see because he doesn't like to be held. Yeah, he's still a work in progress with that. He's pretty new to me. I can't find him. There he is. He's supposed to be a lot bigger than this. He is stunted in growth because my brother kept him in a really small enclosure. So now we're just on the ways to try to get him to be full-sized. I think it's a female, but I'm not entirely sure yet. He told me it's a male, but it's hard telling. But, they're pretty bright green to blend in with their environment because they are tropical lizards. And they are semi-aquatic, hence the name water dragon. They're very different from the bearded dragon, but a lot of times they do get confused. Because if I search a water dragon, bearded dragons always show up. So I'm guessing they get really confused. There's also an Australian water dragon that are more brown and gray and kind of tan colored. But these guys stay green and they can have blues on them. They can eat. They're mostly insectivores, so crickets, mealworms, superworms, giant mealworms. They can eat fish, but you have to be really careful because pesticides and tons of stuff that they can have wrong. Never catch outdoor crickets because they can have parasites and pesticides that are really harmful to the lizard. So always get store-bought crickets and mealworms and all that stuff.
You're the organic. The organic insect.
And he has water in his enclosure so he can go in there and jump. He likes to jump off his hammock into the water. And they also don't understand transparent glass. They don't understand that's a barrier. They kind of just try to go through it. So usually you should have a reptile tent, but I do not have one because he's just been raised in glass, so he's kind of used to where he needs to go. Sometimes he does get a little confused with it, but for the most part he's okay. And they do need high humidities because of the water and being a tropical lizard. They also, I forgot to mention this with bearded dragons, they have femoral pores, so they can get clogged. And only two types of species have that, and that's the iguana and the bearded dragon. They're the only ones that have femoral pores. A reptile tent is basically like a human tent. It just doesn't have any see-through barriers, so they don't get really confused by it. It's actually pretty great. It's way cheaper than a lot of the glass terrariums that you see. But desert species shouldn't really have that because they need really hot. So I would not want to do that for a reptile tent. But
That is so cool.
we're still working on the hand training him. Yes, I can hear you talk.
Okay, good. I was like, I don't know if my microphone's working.
Yeah, we're still working with him.
Does anybody else have questions for Riley? He is super cute.
And he's very timid. He has recently been taking the mealworms off the tweezer if I hand it to him, which is big improvement.
Oh. So can you train them like dogs to sit, to roll over?
You could probably do that with the monitors. They're really, really intelligent.
That's awesome. How much time do they spend in water?
I've seen him in it for like 10, 20 minutes.
Okay,
They'll probably differ between all of them.
cool.
But his terrarium now is way bigger than his old one.
That's crazy.
This
And you
critter,
said this is the one that was your brother's?
yes, this critter catcher is wider than his old terrarium. It was
That's
really.
awesome.
They moved from San Diego because he was in the Navy, so he traveled all the way from San Diego in a car all the way here, which is
You're kidding me.
yeah. So it's really incredible that he made it.
That's quite the journey. Oh my goodness.
Mhm.
How cool. Well, thank you, Riley. You are so knowledgeable about your dragons, about your lizards, which is so important too, and you take such good care of them. Everybody give Riley a round of applause. I love learning about your little critters. I appreciate you taking the time to do that.
Thank you. I could talk about my other baby bear dragon just to show like the difference.
Sure.
So my baby bearded dragon, he is from a pet store.
I think we lost your video.
Yeah, I turned it off because
Oh, sorry.
he's not out.
Oh, okay. I was like, oh no, I can't see him.
uh, he has. I got him when got him from pet store, which is not good. I don't recommend it for anyone. Don't do it. And this is the reason why. I'm about to explain why you never do it. So, my baby beard dragon was there, and he was super skinny, like very, very skinny.
Oh,
He could barely lift his head up. He had a deformed back foot, where his toe was under his foot,
yeesh.
which made it really hard to walk. I don't think it was mad block bone disease, which is the lack of UVB, is how you can cause that, which can cause deformities to all limbs. But sadly, he did lose that toe that was under, so he is
That's
missing a toe. And then he also had really bad deficiencies and like a lot of vitamin deficiency. We thought they may have been impacted.
Can the vitamins be impacted by the lack of light?
Possibly, but you can also calcium dust. But when I first saw him, he was alone and he was trying to hunt, but his eye was weird, so I think he may have got sand in that eye. By the way, this was months ago now, so he's
Interesting.
a lot better now. And so I thought, if he's alone, he has the best survival chance. So I'll just keep an eye on him, check in on him every once in a while. And then the next time I went, there was like 5 other lizards in there with him. So now I was like, oh, now he can hunt because they'll just catch all the crickets before he can even get anything.
Oh,
So I did end up getting him.
so that's how you picked him out?
Yep. And they even, when they grabbed him, they're like, oh, you want the skinny guy? And I was like, if you know he's sick and you didn't do anything for him, I mean, it's kind of sad. Like,
Oh,
they didn't do anything for him and they knew he wasn't okay.
You have such a compassionate heart, Riley. That's so sweet.
I can get him out. I just have to put the water dragon back. So, but he's a lot bigger now, and he's a lot stronger. He runs around like nothing ever happened to him. He eats like crazy. He loves veggies.
That's awesome.
Yesterday he was literally scratching at his veggie dish because he wanted veggies.
That's hysterical. He was begging for more.
But here's another
That's
thing that I want to add. Never ever put two lizards in the same enclosure. It's really bad when you do that because you can't tell if one's sick. Because if there's no food, you can't know, did he eat anything or is it just the one lizard that ate it? Um, and
ah.
you don't understand a whole lot of it. If I put my baby dragon in with Gilbert, my adult, Gilbert would most likely eat him because that's
Oh
what
my
they
gosh.
wanted. Yeah, so it's never ever okay to put them in the same enclosure. Even as babies, I wouldn't suggest it, as they seem to get along. Once they mature, it'll be game over. So they do not like. They're not sociable. They don't like other lizards.
That's crazy.
It is bad. My brother kept the water dragon in with another water dragon, and my sister-in-law, his wife, said, "Well, they got along." And I was like, "Just because it's too small of an enclosure for them not to get away from each other."
That's crazy.
Yeah, if you want to house two bearded dragons together, I wouldn't suggest it. But if you did, they each need at least 40 gallons, which means you'd have to have an 80-gallon enclosure to even try to keep them, but make sure they're the same size. Females are probably going to get along better. Still won't suggest it, but if you really are wanting to, do a lot of research about it because it's.
Wow. Yeah, I actually wondered that myself why they were all in their separate enclosures. So that's super, super interesting to me because that seems like a lot of maintenance to have a different terrarium for each one, but that makes sense. Well, thank you again, everyone. Give Riley some love in chat. We super love hearing her expertise on all her little lizards, or not so little lizards. Awesome. So yesterday my computer like shut down, wouldn't turn back on. It was not happy. It did a mini crash. I don't know. I was able to get it up last night. So many of you emailed me and were like, I can't get into the quiz, and I couldn't fix it and I couldn't email you because I couldn't get my computer to work. So, as of now, you should be able to see that. Let me know. I know some of you are pretty quick at checking that. If you guys want to check that, you are welcome to. Okay, Maria, perfect. You can see it. Yes. So those both 4.01 and 4.02 should be done or open today so that you're able to take them. I don't think I made any of them due until today and tomorrow versus yesterday because of that crash. Yes, and that's also why the postings were late, the YouTube postings. Those are also, I did that all late last night because I was stuck. I was stuck without a laptop. So that, Maria, you're on it. That is why there was a delay in getting those to you. So sorry about that. Also, if you emailed me about that, my apologies. That is that is what happened, and I did not get emails returned quite yet. But I will get on those after class. So today we're going to look at the two subsystems of the nervous system, what makes up the central, what makes up the peripheral. We looked at some of this yesterday, but we're going to take a step deeper into it today. I'm going to try to get through it and get through it quickly because I promised you today would be semi-short. We just got we got sharing yesterday and class went longer. We didn't get through as much as I wanted to yesterday. We talked about the main part of the nervous system being made up of in a human body, the brain, our spinal cords that go down our neck, down our back, and nerves that run like little wires throughout our entire body. And anywhere that you are going to feel anything, you will have nerves. So you can feel your fingertips. When you touch your fingertips, you can touch your toes, right? Wiggle those toes. You can feel things on your toes. So you have nerves that run from the top of your head to the very tips of your toes. And you know that because you can feel those things sensed. Your mom's gotten your nerves burned before. How crazy. From like an incident like that when she like touched something or because of a procedure? Yeah, that's crazy. Bless her heart. So the brain and the spinal cord are what we call make up our central nervous system, and that's what you think it sounds like, right? This is command central station for your body. All right. Both parts, all of the other nerves in the body form the peripheral. So the peripheral will be everything you see in blue. Okay. And your central nervous system is going to be up here in red. Central nervous system, the blue being your peripheral nervous system. So let's use our tools and point to the peripheral nervous system. Everyone point to the peripheral. Where's the peripheral? Good. I'm seeing more pointers. Where's the peripheral nervous system? Good. The peripheral is all of that blue. And where is our central nervous system? Good. Our central nervous system is our brain and our spinal cord. Good. You're on it. Thanks for participating. I love seeing all those little pointers. Let's take a peek at our brain. All right, so our brain is actually divided into two hemispheres. All right, just like the globe, right? The globe is divided into what hemispheres? Anyone remember? Where's the hemisphere on the globe of the world? Good, Bree. Around the equator, right? That's the line. That's the central division. What are the two hemispheres called on both sides of the equator? Good. The northern and southern hemisphere. Who knows what part of the globe we live in? Do we live in the northern hemisphere or the southern? Yes. Northern. High five. Yes, the northern hemisphere. I always like to say, what is so special about that band of the hemisphere that goes around the globe? What is unique about that? That is the fattest point of the globe, right? As it's the very outer point of our world. And if you go around the hemisphere, rather it be where it is all the way around, you're going to find some of the warmest temperatures on Earth are going to be right there around the hemisphere. And a lot of the times, those are going to be your Rennie, those are going to be your rainforests. We're talking about the hemispheres of the globe. And now we're going to talk about the hemispheres of the brain. All right. And unlike the globe divides it into like a north and south. the brain hemisphere divides it into like the left and right. All right, it's a little bit different. Because our brain is so complex and in charge of so many different things, we really break it apart into different regions, all right? Just like there are different regions on the globe, like our continents, right? We've got the continents on the globe. We've kind of got like our continents of the brain. We have the corpus callosum. Anyone want to get on your mic and say corpus callosum? That is right here at the top of your forehead. Everybody give it a good old knock, knock, knock. Underneath this part of your skull is the corpus callosum. Isn't that just a weird word? Like, who decided to name something the corpus callosum? It's right here underneath the front part of your brain. Everybody feel your brains. I'm watching you on your webcams. Or lack of webcams. No one on today? I saw Kaden pop on. I know Jana's here. Where are all my... There's Peyton. Everybody feel that front part of your forehead. This is where your corpus callosum is. As you go north on your head, you're going to... This part of your brain, this region of your brain is called the cerebrum. Cerebrum. Everyone say cerebrum. Not feeling yourself, that's all right. As you continue back, all right, you're going to continue back closer to the back of your head. All right, the back of your head. Always feel like this is the part, like where kind of the crown of your hair is. I feel like it's the point where it's like you have a headache. If I go like this on the very back part of my head, I feel like that always feels good. Back here, this is your cerebral cortex. Cerebral cortex. And then back here, clear at the bottom, this is where what we call our cerebellum. Cerebellum. So our corpus callosum, cerebrum, cerebral cortex, cerebellum, and then we get clear back in here where you're going into your neck. All right, if you feel the upper part of your head, it's not going to be even down your spine yet. Clear back here underneath your hairline. That's where you're going to have your cerebellum. Or your cerebellum and then your brainstem. Your brainstem is a super important place because all of the nerves that are coming from up here are kind of gathered right here. Kind of like when you have an extension, a bunch of cords, there are actually casings for extension cords that you can get that all your wires are going to run through it. That's kind of like what the brainstem and the spinal cord do. All right, it's a casing for all the nerves that are running from your head, from your brain, all the way through your body. Yes, having some bad headaches. You know, there are a lot of things that can cause bad headaches. A lot of times it has to do with hormones, believe it or not. Hormone production, underproduction, overproduction. Sometimes it has to do with our sinuses. Okay. Sometimes when I get the different weather systems come in, like the rain that came in, the sinus pressure that I get from those will cause headaches. Interesting, but it was something that was going on in your brain. I'm guessing it's going to be something that happens in your pituitary gland. How interesting. Yes, so it's corpus callosum, cerebellum, cortex, or sorry, corpus callosum, cerebrum, cerebral cortex, cerebellum. Those 4 parts of your brain. All right. Your limbic system is this little set of tubes that are running through your brain. Then you have your brainstem and your spinal cord. Yes, there are 4 other parts of the brain, the temporal, occipital, parietal, and frontal lobes. The hardest thing about that is we kind of have to open up the brain to see all of those. It can be a little bit trickier. It's sometimes easier to see when you do a dissection. All right. This is an MRI. All right. So an MRI gives us imaging. Oh, yeah. Oh, I like that, Josh. That is good. Right. Absolutely. The spine is very brittle. What the spine is, um, outside of, you have the spinal cord, and then we have the actual vertebrae, and the vertebrae are going to be that armor that goes around those nerves for protection. You're absolutely right. All right, this is an MRI. A lot of times they'll run MRIs if they suspect there being some kind of trauma to your brain or nervous system. All right. This gives us really good imaging of the inside of your brain. But look at all of the folds of your brain. All right. What those folds do is that if you could actually unfold all of those spaces that you see, and it would actually be even larger. Does that make sense? So it increases what we call the surface area of your brain by having all those little folds inside. And I love that you can see those here. All right, it increases the surface area. Why do you want to increase the surface area? Well, you increase the amount of space for information and messaging. All right. What is a neuron? We talked about what a neuron is, right? A neuron is a what? Everyone type nerve cell. It's a nerve cell. It's just a cell. Good. It's absolutely an information transmitter. A neuron is a nerve cell. All right. It's a cell that is a part of the nervous system. All right. And we talked about yesterday these little extensions. What are these little extensions, the shorter extensions called? Does anyone remember? Almost, Chris. Remember, the smallest part is the longer word. So these are the dendrites, and then the longer extensions of the nerve cell, the neuron, is an axon. All right. So everybody point to an axon in this nerve, on this neuron. There's multiple. An axon is the longer part. Good. So these are longer. This is longer. These are axons up here. Yeah. These are axons off the neuron. Where is the dendrite? The dendrite. Good, there's multiple dendrites too. These little smaller fork-like extensions or little tree-like extensions. These are even dendrites down here. Dendrites are the shorter pieces, all right? What neurons do is they receive signals from other neurons, all right? They are a network, an information system network of our body. They do this series of rapid firing. I wish we were all in person, or I wish we would all put our webcams on and put our hands out like this. Those of you that are on, will you stick your hands out like this to both sides of you? I'm looking for you. Have you ever played those games where you sit, like you might have done this more in elementary school, where you sit in a circle and you like do like the hand claps in a circle? So like I would clap this hand or clap this hand and then the next person and it would go in a circle. Just like the domino effect. So like if I go over this way and then the next person I would clap their hand and then they would clap the next person's hand. We could all go across the screen. Look at least at your webcams. Like if I could clap Riley's hand, Riley's next to me on my screen, and then Riley could hit Braxton's hand, who could hit Ellie's hand, who could hit Connor and Kylie. Then Kylie hits Micah, then Micah hits Mackenzie, then Mackenzie hits Jared's hand all the way through, right? It's like a domino effect. One neuron sends it to the next, which sends it to the next, which sends it to the next, to the next, to the next. That's how it works, but it happens very, very quickly, okay? So this is a microscopic image, and it shows a motor neuron's nerve endings, okay? When a muscle, like these stripes right here, these are your muscles, okay? When a neuron fires, it releases a chemical into a space, and it causes this domino effect. I'm glad you guys are at least relating. One neuron firing sets off another, and it's a chain-like reaction, and that goes all the way up to your brain. And then, like we talked about yesterday, those stimuli, responding to stimuli, like our muscle responds to that stimuli by when it gets a message back. So it goes all the way to the brain. Those firings go all the way to the brain, and then those firings go all the way back as a response returns. I wish we could track that because I think it would be super fascinating. I might have to look for a video of that. All right. But they work a lot like electrical circuits. These are actually neurons firing in this picture. You can often, they do electronic testing when they monitor our nervous systems because they actually do operate on little currents, electrical currents. Okay. When a neuron fires, it sends an impulse to one or more neurons, and those are coupled directly, and they send them passing to another up your spinal cord to your brain and back. All right. They use chemical messengers known as neurotransmitters. All right. Neurotransmitters. So that's a word that I want you to pull out of here. Neurons use neurotransmitters to send signals to other messages. Think about some ways that you send messages, all right, to people. So let's think about ways that we communicate. So neurons use neurotransmitters. I can, send you a text. I could write you a good old-fashioned letter and send it in the mail. Or I could electronically send you an email. Kylie, do people call people these days? Yes, they still do. You can call somebody, right? Text people, send letters and emails. What are other ways you can communicate? Think of some ways that I communicate with my children. Talking in person, conversation. What about when I look off my camera like this? How am I communicating to my children? Good. Facial except like there's nonverbal ways of communicating, right? Communicating. We use sign language, we use facial expressions. Right? Morse code. Yeah, we have lots of different ways of communicating. Some that are more formal than others. I'm going to just use my verbal communication. Girls, get out of the garage. Where are you? There we go. Use our voices even. They took their fake ice cream cart and disappeared into the garage. It was a little bit concerning as we talked about communication right there. This is our last unit, I believe, before the exam. So yes, we all communicate a lot of different ways. Our nerve cells use neurotransmitters to send those signals and communicate with each other. So if you need like a mental image, I want you to just think about neurotransmitters as a text, a neurotransmitter as an email from neuron to neuron, right? Just like birds chirp, dogs bark. Riley, how do lizards communicate? Do they communicate? That would be a good question for you, Riley. You'll have to come back to me on that one. How do lizards communicate, or do they? I have no idea. How cool is that? So those neurotransmitters contain chemicals. How cool is this picture? Okay, this is a legit picture. So this is what a type of microscope. It is a extremely expensive type of microscope, and you can see. Look at each one of these dots. I'm yawning. It is a electron microscope. You can see the nerve endings, and it has been broken to reveal some vesicles containing the chemicals in them. So the orange and blue are actually the chemicals that they use to pass the messages. So basically, those are like our hands. If we're using our hands to communicate with sign languages, these are the messengers right here inside the nerve cell. That is what they use. Ooh, interesting. They bob their heads, they wave, they hiss. Very good. They puff up. Nonverbal ways of communicating. Good. That's cool, Riley. And our cells are going to use these chemicals that we can see inside this neuron right here, those blue and orange particles, to communicate with one another. Let's come back to this. This is just showing you what happens when you use illegal substances. They're illegal substances for a reason, right? Because they are destructive to your body. They are destructive to your nervous system. And you can see the loss of those yellow regions within the brain when you have someone that is illegally using substances that hurt their brain. So this is a brain of someone that's on. Yeah, isn't that terrible? So I don't know, sometimes people get bad raps of why you can and can't use things, and it's your body and it's your choice and whatever else. But what happens is you also start losing good judgment. When you start losing the your brain composition. So yeah, not a good situation. How does the brain change so much? You're killing off cells when you use those substances. You are legitimately killing off part of your brain is dying. Absolutely. Yep. How would the toxins get to your brain? When you do illegal substances, that might be something you inhale or even take. Yeah, it gets in your bloodstream, right? And where does your bloodstream go? Your nose? I mean, yeah, any of these things. anytime you're putting anything into your body, whether it be via your nose, your mouth, your lungs, it all of those go into sinuses that go to your bloodstream. And that bloodstream goes to your entire body, every single organ. Yes, your brain, yes, your heart, yes, your nerves, yes, your kidneys, yes, your stomach. All of these major organs that you need to function. Yeah. So, like, the reason that these substances are illegal is because they damage your body in ways, and unlike some of our skin cells, nerve cells often don't replicate themselves. So these are not cells that often are going to regrow or replicate. That's why when yep, your eyes are they're not an organ, but they're a part of an organ system. Because that's why um when you do these substances, they do damage that is irreversible. When you kill certain cells, especially in the nervous system, when has anyone ever had a loved one experience a stroke? Stroke? Yeah, my grandma experienced a stroke. But what happens is it's when circulation gets cut off some area in your body and you don't get blood to a certain area. Yeah, they probably passed because they did not get blood to a certain area of their brain. And when you don't get blood to your brain, those cells die. And those areas of our cells of our brain often do not regenerate. And we need our brain, right? We need all of those different areas of our brain to tell our body what to do and how to function. And that's why a lot of the time it is so severe, and a lot of times it does result in death. I know we're going long, I'll finish it up here. But when my grandmother had a stroke, she was lucky enough to make it through, but she wasn't able to speak anymore. She wasn't able to talk. She wasn't able to feed herself. She became paralyzed from the waist down. So yeah, guys, we want to take care of our bodies. You're young, right? You're young and we've got lots of choices ahead. And yes, you can choose to do a lot of stupid things. Can, tell you as I've grown that the stupidity of decisions that I made in the past and I never did illegal substances, but I've made stupid decisions in my life that become much more clear as I've aged. But the reason that our government and society makes some of these things guidelines for health and stipulations for things as to not use is because they can create permanent damage to your body that you can never get back. Never ever. All right, and they have major repercussions on you the rest of your life. And where death is hard. Sometimes being in those situations where you've lost brain function and you're still here and you can't do some of those things that you know you can't do. Like my grandmother was very well, like cognitively there. She hated that she couldn't speak. It made her so frustrated. You could see it in her eyes because she would cry when she couldn't do things that she was trying to do and that she wanted to do. Those are much those are those are incredibly difficult situations to live through. So, what does this tell you today? Don't do drugs. All right. Don't do illegal substances. I love you. Your purpose is so much greater than you realize right now. Your influence is so big. Who you are is so special. And we talked about that in reproduction. It's not something that easily happens in each one of your lives. Each one of those cells coming together and developing and growing is a miracle. A miracle. A miracle that was very difficult for me and my children to get here. And I want you to know that you're each a miracle. And have such amazing potential and purpose. There are people in this world that need you. There's no one else like you, and this world needs you. So let's, yes, seriously, truly, I want to speak that into you. If I speak nothing else into you, you remember nothing else about biology. I do want you to remember that you are the only one of you in this world. And everyone might not need you, but there are people in this world that need you. And something that only you can bring in who you are. So the content is fixed. The quizzes are there. So go ahead and work on those quizzes today. There's the 4.01. I didn't see your joke. I'm sorry, Jana. I was like in my I love you all. You all mean so much to me zone. Kaden, you bring so much. I will personally write you an email and let you know. I promise. You each do. You each do, and you've each brought so much to me in my life personally just from being in my class. So, well, your other teachers are all gonna hate me because we ran late because I got on my little preaching podium about your value. So, have a wonderful, wonderful day. Your value is great. There are great plans for you ahead. Have a wonderful week. Finish those quiz. Oh, thank you, Kinsley. Have a great day. I will see you on Monday. We have map testing Thursday, Friday. Make sure you get there. I love having you share. Thanks for being such a good teacher to us, Riley. Thanks, Maria. Yes. Go kick some serious booty on those map tests, everybody. Bye.